We're going to finish up chapter 19 today, so we're going to look at assumptions and conditions, and we're going to look at a couple more examples of creating confidence intervals, and then wrap it all up. But we're going to start with assumptions and conditions. So every model depends on assumptions. We can decide if an assumption is plausible, but we can't verify it, which is why we have to have conditions to make sure that our assumptions are met. Again, to try and verify our assumptions, we have to check certain conditions, and those conditions can be verified. And as we go through this, you'll notice that the assumptions and conditions tend to be the same and kind of repeat themselves, so it'll be a little bit easier as we move forward. Conditions are often about the data that we can check and see whether an assumption is at least reasonable. Again, as I just said a second ago, conditions are often about the data that we can actually check to make sure an assumption is at least reasonable. So the first one is the independence assumption. So we have to make sure that our data is independent. The data values are assumed to be independent by checking three conditions. The plausible independence condition. Is there any reason to think that the data values somehow affect each other? This typically depends on the knowledge of the situation and not the data itself. Does it seem reasonable that they would be independent? For example, flipping a coin. It seems reasonable that if you flip a coin once, that outcome is not going to affect what happens if you flip it a second time. Then we have the randomization condition. This one we can check. We can see, were the data sampled randomly? And the problem should tell you if it is random. And then we have the 10% condition. Usually we want as large a sample as possible, but when we have a small sample population, the probability of success may be different for the last few individuals we draw from. Therefore, we really only want to have 10% or less of the population so we can pretend to have independence. And again, you would check this by taking your population size and multiplying it by 10% and making sure that your sample is less than that. If they don't give you what the population size is, then you take your sample size, multiply it by 10, and state that the population should be greater than that value. Then there's the sample size assumption. The model we use is based on the central limit theorem. The sample size must be large enough for the central limit theorem to work. For this one, we only have to check one condition, and that's the success-fail condition, so where we're going to expect at least 10 successes and 10 failures. And again, we check this by taking our sample size and multiplying it by our probability of success, and then taking our sample size and multiplying it by the probability of failure. So as long as we have 10 of each, we're good to go. And we'll do some examples showing that we have checked the assumptions and conditions. Like right now, our first example. In 2002, the Gallup poll asked 537 randomly sampled adults if they believe the death penalty is applied fairly or unfairly. From this poll, 53% said fairly and 7% said that they did not know. So we want to know, what can we conclude from this survey? Well, before we can do anything to try and conclude anything from this survey, we have to check our assumptions and conditions. So we have two assumptions. We have the independence assumption, of which we need to make sure that it is plausible that they are independent. And in this particular case, it does seem plausible that one person's response will not necessarily affect another person's response. Then we need to check that they were randomly assigned. So in this case, we need to state, so they specifically told us that it was randomly sampled. So the poll was stated to be randomly selected. Then we have our 10% condition. So for our 10% condition, we don't know what the entire population size is. We're going to assume that it's all of the US, but we do know that our sample size was 537. 537 times 10 is 5,370. It's safe to assume that in 2002, there were more than 5,370 U.S. adults. The last condition that we need to check is our success-fail condition. So our success-fail condition, which I'm kind of just going to do up here, success-fail, we need at least 10 successes and 10 failures. So our successes would be 0.53, a probability of success, times our sample size, which is equal to 284.61, and this is greater than or equal to 10. Our failures would be calculated the same way, but if our success is 0.53, probability of failure then is 0.47 times 537, which is equal to 252.39, which again is greater than or equal to 10, so we're good there. So we've checked all of our conditions. They're random, we have 10% condition is checked, and our success fail, and we've shown all the work for each of them. So this tells me that we are completely good to go on and continue with our example to find the true proportion of the number of adults that believe that the death penalty is applied fairly. So in our example, 53% said that it was applied fairly and 7% said they didn't know. This means that our proportion of success is 53%. 53% said they applied it fairly. I know 7% said they didn't know, so then only 40 said that they did, but it's just P hat and Q hat. So that means that 40%, or 47%, excuse me, said that they don't know or that it's not applied fairly. And then N in this case was 537. So again, to calculate your confidence interval, it is your sample proportion plus or minus your margin of error, where your margin of error is equal to your critical value times your standard error. So we need to know our critical value and our standard error. So I'm going to go ahead and calculate the standard error first. So in this case, my standard error is equal to the square root of 0.53 times 0.47 over 537. And this ends up equaling 0.022. They didn't tell us what our confidence level is, and when this happens, just go with 95%. That's just the easiest. So then my margin of error, my critical value for 95% confidence is 1.96 times 0.022. So my margin of error ends up equaling 0.043. Now that I have my margin of error and I know my sample proportion, I can calculate my confidence interval. So my confidence interval is going to be the 0.53 plus or minus 0.043, which gives me a confidence interval of 0.487 to 0.573. So this is my confidence interval. Now the important part is that I interpret this and explain what this actually means. So again, when you do an interpretation, you have to include three things: your confidence level, your interval, and what it is telling you in the context of the situation. Based on our sample, I am 95% confident that between 48.7% and 57.3% of all U.S. adults think the death penalty is applied fairly. So again, I've explained how confident I am, what my interval is, and then what it means in context. And note I'm talking about all U.S. adults, not just our sample, but the entire population parameter. Choosing your sample size. So I told you guys in class yesterday that the larger the sample size, the better. And actually we even kind of just heard that as well when we were talking about our assumptions and conditions. But again, everything tends to get better. You can be more confident and have a more narrow confidence interval and a smaller margin of error if you have a large enough sample size. So as long as your sample size increases, your interval can become more and more narrow and you can become more and more precise, which is kind of what we want. So the question of how large a sample to take is an important step in planning any study. So you have to figure out how many people do we actually need. And in fact, when you guys were creating your own samples, when we did our experiment earlier in the year, I ended up capping you guys off, but that question kept coming up. How many people should you select? And it's an important step to figure that out. A good way to do this is to choose a margin of error and a confidence interval level. So figure out how confident do you want to be, 90, 95, 98, 99, and then select a margin of error. So do you want a margin of error of 3%, 4%? Once you select those, we can then use the formula, which requires p-hat, which we don't have yet because, again, we haven't taken our sample yet. We're still designing it. We haven't actually gathered any data yet. We're just trying to figure out how big our sample should be. So what we do in this particular case is we actually end up using 0.5 for p hat and then therefore 0.5 for q hat. The reason why is because 0.5 times 0.5 will give us the largest value for p hat, and therefore that'll give us the largest value for n. So we then solve the formula. Margin of error is equal to our critical value times the square root of p hat q hat over n, where this is our standard error. And we just end up solving for n in this case. So you'll have to do a little bit of algebra. So let's go ahead and look at an example of this. What sample size does it take to estimate the outcome of an election with a margin of error of 3%? Remember that our margin of error is equal to our critical value times our standard error, where the equation of standard error is p hat q hat over n. So my margin of error is 3%. My critical value, they didn't tell me how confident to be. So again, I'm going to go with 95% confidence. So my critical value is 1.96. Then I use 0.5 for p and 0.5 for q, all over n. And then I solve. So the first thing I'm going to do is divide by 1.96. This gives me 0.015 equals the square root. 0.5 times 0.5 is 0.25 over n. I square both sides, and we end up with 2.34 times 10 to the negative fourth equals 0.25 over n. I multiply by n on both sides, so we get n times 2.34 times 10 to the negative fourth equals 0.25. Then we divide by 2.34 times 10 to the negative fourth on both sides, and we get that n equals 1067.11. You always round up. We're talking about people here, so it has to be a whole number. So in this case, our sample size would be 1068, and that would be our final answer. So then what have we learned within Chapter 19? We've learned to create our interval with a margin of error. This provides us with a level of confidence, typically 90, 95, 98, or 99. The higher level of confidence, the wider our interval will be. Therefore, the more narrow our interval is, the less confidence we have. A larger sample size is always better, and it will make our interval more narrow. If you do want a more narrow interval, you can do that by increasing your sample size. You always want to calculate a sample size for the desired degree of precision, which is our margin of error, and our level of confidence. You have to check your assumptions and conditions. And again, it's not enough just to list them and put a check mark. You must actually check them. And then lastly, we've learned to interpret a confidence interval by telling what we believe is true in the entire population from which we took our random sample. Of course, we can't be certain, but we can be confident. And that is it for Chapter 19. Have a great night, guys, and I will see you tomorrow.